These last set of notes is more for definitions. So two definitions you're going to learn about is the angle of elevation and angle of depression. You'll need these to make sure that your triangle that you draw is drawn correctly and where the angles will be located. Angle of depression, if you see this, so say there's a person standing down here and they're looking up at the top of this lighthouse, that's their line of sight. So if they look straight across a horizontal, this angle formed is the angle of elevation because you're looking up, so it's elevated. Say you were standing at the top of this building up here, or this house, the horizontal line of sight is out. If you're looking down on something on the ground, say it's a tree. Sorry, that's a badly drawn tree. There we go. The angle of depression, so how much you need to turn your eyes downwards, the degrees you turn your eyes to change them of the direction is your angle of depression. Now something I want you to look at for this next picture, if someone's standing down at the bottom of a cliff, someone's standing at the top, and they're looking at each other, you can see the angle of depression is how much this top person has to look down from looking straight out. The angle of elevation is how much this person has to turn their eyes upward to see the person up above. But I want you to notice something. These two horizontal lines are parallel to each other. So wouldn't that mean that this line going through the center is the transversal line, and the angles created by them, so our angle of elevation and angle of depression there, both of those, that they are congruent to each other. So will the two angles shown be congruent? Yes. So that will help us when we are filling in our pictures, that these alternate interior angles are congruent when we fill in some different measures on our pictures. If they give us some different measures, that we can put them in the picture in different places. In number 1, we need to draw our picture first. So we have an angle of depression of a car from a hot air balloon basket. So let's draw a hot air balloon. And the person up in the balloon is looking down on the car. So that's our angle of depression. So we're creating a right triangle when they're looking down on them. Now remember, our two lines are parallel. So if I draw a horizontal line going out, this is really the angle of depression, and that's 45 degrees. But if we said the angle of elevation and depression are really congruent, that means in my triangle, the measure I need is my 45 degrees right here. So these two are congruent. So the number they give us is really this outside number, but I need to put it in my triangle. So make sure it's down here on the ground, not up at the top part. Next, they give us that it's above a water tower. That just tells us what's down here, so we're going straight down. And that water tower is 5 kilometers from the car. And we need to find what is the altitude going up and down. So once our picture is drawn, we do the same thing we were doing on the previous ones. We know it's 45, 45, 90, so our ratio is x, and then x square root 2. So we need to label the sides in our triangle. So you have x square root 2. The only side length we have is right here, our 5. So I set my ratio equal to that number. That means that all of my green x's will be 5. So I can put those into any of the different pieces. And I can see that the altitude, or the height of the balloon, is going to be just a plain 5 kilometers, because that's what it is right over here. If I wanted this direction, I would have to take 5 and then multiply it by the square root of 2. But they're just asking for the height of the balloon, so I want the 5. This next question is a pretty typical one with a ladder. So you have to draw a house, and we have a ladder that's leaning against the side of the house. So make it big enough, even though it's not really going to be that big. And the angle of elevation is 60 degrees. So that means it's down at the ground. So the angle of elevation from the bottom of the ladder is 60 degrees, which means my top angle will be a 30. And the base of the ladder is 7 feet away from the house. So down here in the bottom is going to be 7 feet. How long is the ladder? Remember, here is the ladder. So we need to find out the hypotenuse of it. We also want to find how high off the ground does our ladder reach. So we have to find both sides of our triangle. This is a 30, 60, 90 triangle, so our ratio is going to be x square root 3, and then 2x, so let's label the sides. Our x, remember, is across from the 30, so that would go here. Our x square root 3 is across from the 60, so that would be my height up and down, and my 2x is my hypotenuse. The only piece that we have is this one right here, so we set the ratio equal to the side length they gave us. Now all of my green X's are going to equal 7. So if I put each of those in, over here for the height, I have 7 square root 3. For the length of the ladder, we have to take 2 times that 7, so I get a 14 for the length of the ladder. Make sure you label your answers and not just circle them on your picture, because otherwise someone else that looks at your paper may not know which number goes with which, and we want to make sure you are also clear of what you need to find. This very last one is about an airline or a pilot taking off, and we need to draw our picture again. So they have a runway. They need to reach a cruising altitude of 10,000 feet. Remember, altitude means height. So at the end, we need to be up here at 10,000 feet. So that's our height up and down. There's my crew drawing of where my airplane is starting. And he takes off at a 30-degree angle. So he's starting on the ground, remember. He's not landing. He's starting off on the runway. So down here is 30 degrees. We know up and down has to be 90, so that means the remaining angle is going to be 60 degrees. Next, we want to find how many feet does he fly through the air. Now notice it says it's not the ground distance. So it's going to be up here. We need to find where is he actually flying through the air before he reaches that cruising altitude. We know this is 30, 60, 90, so our ratio needs to be x square root 3, and then our 2x. So if we label our sides, this is the smaller side. Our medium would be our x square root 3, and our 2x is over here of the side that we need to find. We have the height, or our x, so we set that part equal to our ratio. Now all of our green x's equal 10,000. So we can go back and put them back into any of the sides in the triangle. The piece they wanted, though, was the hypotenuse. So we need to take 2 times that number, and we get 20,000. So that means that the distance he needs to fly before he can reach cruising altitude would be 20,000 feet. If you have any questions for your teacher, remember, go ahead, write those down. There's not a specific spot for it, but you can use the back side of your notes if you need to.